Hey there, everybody. Hi, I'm Phil Lamar, and welcome to NASA's Ask the Astronomers Live, the show where we have real live scientists here to answer your questions about the universe. And to find out about upcoming shows like this one and to see lots of fun astronomy videos, you can visit our website at universeunplugged.org. That's .org. We're not trying to take your money. Okay, today we are talking to some great astronomers about exoplanets, which, as I found out a few minutes ago, are planets around other stars other than our sun. Now, we're going to be talking to these astronomers about how they got interested in exoplanets and how they do what they do. So let's meet them. First up, we have Dr. Frisa Morales, who is an astronomer working at NASA's Jet Propulsion Laboratory, as well as a professor at Moorpark College. Hi, Frisa, how are you?
Hi, I'm doing well, Phil. Nice to see you.
It's nice to see you. Can you tell us a little bit about the work you do? Like, what do you call it?
Thank you, Phil. So I call myself a planet hunter. I indeed, as you mentioned earlier, I'm an astronomer at Jet Propulsion Laboratory. I'm also a program manager there for astrophysics and heliophysics research and analysis program. And I began many years ago studying the dust that forms other planetary systems. And I began thinking about why are the dusty systems forming and they have gaps? Why are they coagulating into rings and have gaps? And so I started looking on what's carving the gaps. And that's how I became an exoplanet hunter.
Oh, wow. I love that you talk about dust, but you're also talking about planets. It's like dust is very small, planets are very big. How does that work? Well, maybe our next astronomer can help me answer that question for me. Please say hello to Dr. Nicole Colon, who is an astronomer at NASA's Goddard Space Flight Center. Hi, Nicole.
Hi, happy to be here.
Oh, we're so happy to have you. Tell us a little bit about what you do. Are you also a planet hunter?
I am. I love that term, because it's very accurate, right? What I do at Goddard Space Flight Center, I essentially use data from different telescopes to find new planets. And these are new planets, not in the sense of newly formed planets, but they're new discoveries to us, just planets we hadn't previously known of before. We use things like the Transiting Exoplanet Survey satellite or TESS to look at these planets and basically search the stars for them. So there's actually an image, image number 1. We can show you that there's an artist rendition of TESS, but it's basically just looking at stars over time and finding planets that block some light. And with that, we can find planets that we didn't know existed before.
Oh, I see. So you locate the planets by seeing what's blocking light from those stars that are so very, very far away, right?
That's right.
Wow. That's amazing. Well, okay. Since we are talking, our topic today is exoplanets, and prior to 5 minutes ago, I had never used that word before. Maybe we should talk a little bit about what is an exoplanet.
Sure,
Oh,
Teresa. Go ahead.
Oh, sorry.
An exoplanet.
Teresa?
So an exoplanet is any other body of significant size. And by that I mean it's not a little speck of dust or a little pebble. It would be a body of significant size that has rounded it, or it's made its shape into a rounded body. The definition of planet goes as, and it shouldn't share its orbit as it goes around a star, right? Otherwise we would call it a belt of things. And it doesn't emit its own light, otherwise it would be a star. Now, this definition of a planet or an exoplanet, right, so a planet that's orbiting another star, it's kind of problematic because, for example, we have the Earth that has a body orbiting it, right? So we have the moon, and so they're kind of sharing the orbit around the sun. So in reality, this definition of exoplanet is still kind of, or planet, exoplanet, is controversial. But exo means outside of the solar system. So that's what we mean by exoplanet.
Okay. So, well, and of course, so Earth would not be an exoplanet anyway, because it's not outside our solar system.
That's right. It's an exoplanet to someone else around another star.
But then exoplanets could have moons, right?
That's right. So it's a complicated picture.
Wow, that's amazing. And how do you find exoplanets? Nicole, I think you touched on this earlier, right?
Yes, exactly. So I mentioned Tess briefly, where,
Is that your sister? Tess?
It's my new best friend, actually. No. Yeah, Tess, we use these missions like Tess, and there was also a predecessor called Kepler, where they're essentially looking at stars and just staring at them for a long time. And then as you see something coming in front of the star, I mean, we don't see it directly. It's a very indirect method. We just see a decrease in the star's brightness. That's it. We don't actually see an image of the planet itself this way, but we can see these periodic dips and say, okay, that is something that should be a size of a planet blocking some of the light from the star. And that's one of the main ways that we've actually found over 4,000 planets this way, exoplanets this way.
Wow. So you guys are kind of like intergalactic Sherlock Holmes using deduction, Might call you planet detectives.
Indeed. If I may add, Phil, so Nicole uses the technique known as the transiting technique because the planet is passing in front of the star, transiting in front. But I use a different technique, completely different technique. So I use telescopes from the ground to do what we call direct imaging. So if you bring up image number 5, this is an image taken from the ground here from the surface of the Earth, specifically from Mauna Kea in Hawaii, using the Keck observatories, and we look towards this one star. This is called HR 8799. So these stars have phone number names, HR 8799. And what we do is we use a coronagraph, which is a little piece of plastic, right, put in the path of the light, and you kind of like cover the star a little bit because you don't want to see the star, but you want to see faintly what's around it. And in this guy, around this guy, you see 4 gas giant planets. So labeled here in E, or B, E, or B, C, D, and E, right, is 4 gas giants orbiting HRD 799, which is a star that is about 3 times more massive than the sun, about 50 times more luminous than the sun. But there you go. This is directly imaging planets, exoplanets.
Wow. And you could see that from the surface of the Earth. That's incredible. How did you guys get into hunting planets? Nicole, how did you start doing this?
Well, it kind of started when I was really young, in a sense, not in a formal way, of course. But, when I was younger, I watched a lot of movies, as we do, and a lot of science fiction movies. And I always wondered, if there were aliens, like, where did they come from? What was their home planet like? What stars did they live around? Was it anything like the sun, right? So I was really intrigued by that from a young age. When I was a teenager. And then eventually, I went to college and graduate school, and I ended up attending graduate school right before the launch of the Kepler mission that I mentioned earlier, which was about to revolutionize astronomy. We didn't realize how much it would revolutionize astronomy at the time, I think. But yeah, it was basically like perfect timing for me to join the planet hunting world, and it was, just awesome experience from there.
That's amazing. Farisa, how about you? How did you find this world, or how did it find you?
Thank you, Phil, for asking. If you show image number 6, I have an artist's depiction of a debris disk. So this is the kind of phenomena that I was studying when I went to JPL as an intern initially, and then moved on as an undergrad to the mission Spitzer Space Telescope. And Spitzer was detecting the emission of infrared radiation from dust. And so this artist's depiction shows a couple of rings around a star that is relatively young, because that's when you typically find all this debris left over from when the baby star formed. And so you have these couple of rings, but then in between these rings, you could have planets forming, carving gaps. And then notice you also can have, in this artist's depiction, they show a comet leaving its tail behind, and you can have, through gravitational interactions, like the pulverization of these other asteroidal-like bodies. So by studying this dust and then recognizing that there were gaps, that's what got me started into thinking, like, wait a minute, planets are also debris. And you know what? People living on those planets are debris, right? Left over from when the star formed. So yeah, when I say I study debris systems, is basically studying everything that happens around a star, including the planets.
That's wild. Okay. Let me see. How long have you guys been in the field?
Yeah,
So far?
oh gosh. Well, I'm trying to do math live on TV here. No, I mean, I've been an astronomer. I've had my PhD for about 8 years now, formally, but of course I was studying astronomy in grad school before that. And, it's been a while, but it's been a lot of fun. And I've been at NASA though for about 5 years, first at NASA Ames Research Center in California, and then out to Goddard Space Flight Center in my current job.
Oh, okay. And Farisa, you've been roughly the same time frame?
A little longer, and because I had the privilege, I suppose, to get an internship as an undergrad when I transferred from a community college to UCLA. And that summer in the year 2000, that's when I got an internship at JPL and began working there. And so I've been at this, astronomy, learning to be an astronomer, and quickly after that, learning to study the dust as an undergrad, and then evolve into a graduate program, master's, PhD, etc. So it's been about 20 years.
Wow. And in that time, what would you guys consider the high points in your careers so far, until we have the Morales and Cologne missions? But up until then.
That's yeah. Well, you just gave me an idea to propose a new mission. So maybe this right here is the high point.
Can I do
Sure. I mean, but before this, certainly there have been so many high points. Of course, getting a job at NASA in the first place was, probably the highest point. I'll never forget when I got the job that I have now at NASA Goddard. I was literally flying home from a Christmas vacation, and I had a layover, and it was on that 30-minute layover that I got a phone call saying I got the job. And I just happened to be able to answer. I was in an airport, and I think I jumped up and down in the middle of the airport. I didn't care, right? I was just so excited because it was a lifelong goal, to work at NASA. So that was an absolute high point for me.
Wow. Farisa, what about for you? High points?
Many high points through the years. Obviously, being able or having the opportunity to do research, hands-on experience while you're getting your education, which are sometimes two different worlds, right? One thing is to learn things in theory, and another one is to actually be doing it. And so that is completely invaluable, right? It has no price. And I have to say that having had access to infrared data from Spitzer Space Telescope when it launched back in 2003, and the data was coming in, and we started to see the emission from the dust very clearly, and we started to characterize it. And so then I start plotting things, right? So plot this versus that. Are there any trends? You're looking for things. And I found clear trends. So seeing the observational results, just this is what nature is telling me, and publishing that. And then seeing my colleagues saying, according to Morales et al., blah, blah, blah. I was like, oh my gosh, this is when I started shrinking during a conference. Like I hear all these people quoting my name because of the work that I presented and published, but it was because Spitzer, or this new tool, the telescope, was revealing it, right? And so being able to contribute to this cosmic puzzle, I can die in peace, right? So those kinds of things are really rewarding.
That's amazing. Oh, well, wait, for anybody who is just joining us or missed the beginning of the show, we're here with Nicole Colon and Farisa Morales chatting about planet hunting. That's looking for planets around other stars. And we're also talking about their careers and how they came to be involved and the amazing work that they do. Now, why don't we take some questions from our audience? Let's see. What do we have? Here we go. Oh, this is a great one. Do you guys have any advice for a young person interested in pursuing a career of studying exoplanets?
Sure. Yeah, I can start off with that.
Nicole? Okay.
So, for me, as I mentioned before, there was a keen interest since I was young, where it started with science fiction movies and it turned into science reality in my career. But for me, part of that was just literally, looking for every opportunity, where, whether it was a science camp or, some kind of seminar to watch online. And especially now, there's a lot of virtual seminars, right, that people can reach out to, and watch and participate in. Including this one right now. So, that's a way to learn about what people are doing. But also, don't feel shy about contacting anyone who interests you, anyone who's doing science out there that you find intriguing. So we were, talking about going to study exoplanets. At a young age for me. But my point is that, we were, I was very interested in that. And I think how I got here in the end was ultimately about talking to a lot of people is what I'm trying to say. Talking to a lot of people, connecting, making connections, networking, etc. At every stage of my career. And you never know who you'll talk to, the right person who has the right opportunity, the right internship, right, Farisa? So you never know.
Oh, wow.
Yeah, I want to echo that and second that, right? So if you speak up, if you raise your hand, right, then you will find answers, right? So by looking at those things. But quick advice for a young person or a more mature person. For example, in my case, I was a late bloomer. I started school after I had a couple of babies, and I started at a community college, and I was already, a grown woman with kids and a family and a business. And then it's like, oh, I should go to school. So, young person, mature person with the desire. Obviously, the education is going to help you train yourself to get, access to this information. Right now, if you go to exoplanets.nasa.gov, you can find all kinds of information that, that we're putting up there and that NASA is, releasing all the time from our research. And so just, go seek, go keep asking questions, and young or older, just community college is a great place to start, and then just keep pushing. Yeah, internships, good idea.
Wow, that's so cool. Here's a question. Someone said, I would like to hear about where things stand on learning about atmospheres of exoplanets. Is this possible yet? That is not a question I had before, but now I'm dying to know the answer.
Sure. Yeah. So I can start off on this one.
Well, thank you.
So this is a great question because yes, it is possible. And that's the exciting part is we are in this era, we've discovered all these exoplanets, but we've actually have gone a step further and are able to study their atmospheres a bit. We've been using telescopes like the Spitzer Space Telescope that Farisa mentioned before, also the Hubble Space Telescope. And with these telescopes, we're able to study things like the kind of atmospheric dynamics of a planet. You know, how is the heat transferring from one side of the planet to the other side? Also, we can look for water in the atmosphere of a lot of planets. So those are things that are possible now. But I also want to mention briefly, coming up next year is the James Webb Space Telescope. So I believe that's image number 2 I can show you, which is the James Webb Space Telescope. It's about 3 times the size of the Hubble Space Telescope, and it's going to launch in 2021. And it's going to essentially push to just even higher quality data that we can use to study these really tiny signals that come from exoplanet atmospheres. So we already have, you know, a glimpse from current telescopes in the atmospheres, but we're going to learn even more with the James Webb Space Telescope starting in the next couple years. So that's really exciting.
Okay, Farisa, is there anything you can add to that about
No,
atmospheres?
I second, thank you. I second what Nicole was mentioning. What we study as astronomers, it is said, I think it was Richard Feynman many years ago that described astronomy as an observational science, because much of what we do is just stand over here and look. So we collect photons. We make these big buckets called telescopes, right? And collect all these photons and analyze the light. And so we analyze the light via 2 techniques. We can do something called photometry, which is basically just collecting photons on pixels, or we can do spectroscopy, which is spreading out the light into its rainbow components. And so either using photometry or spectroscopy, analyzing that light, that faint light, that feeble light that Nicole was describing from the exoplanets, and you can spread it out and basically read out that light. For example, brings us information like the composition of that atmosphere, something about the dynamics, the temperature, the architecture of system. It just brings a lot of information. That's what light does. And so indeed, we're very thirsty for continuing to analyze light, especially with this brand new tool, the largest one we've ever launched, right? So hopefully it all works. And we're really looking forward to the James Webb Telescope.
Wait, James Webb is going to be the largest?
Mm-hmm. Yes, that we've launched. Yeah.
Wow.
Yeah, it's about 3 times bigger than Hubble Space Telescope in terms of diameter. Yeah.
Amazing.
So 9 times more powerful or so.
Yeah.
That's amazing. Oh, this is a hot off the presses question from that one guy in your class. A pleasure to have you guys. As of yesterday, phosphine was detected in Venus's atmosphere, indicating that facultative anaerobic life may lie underneath. What are your thoughts on this discovery? Nicole, any thoughts on? And I won't make you have to say facultative anaerobic 5 times fast.
Thank you. I appreciate that. Yes, I do have some thoughts. First, it's really exciting to have this type of detection because this is a brand new detection. As far as I'm aware, phosphine had not been detected in Venus's atmosphere previously to this study. And, this is really interesting because there's been some work done suggesting that it is a type of what we call a biosignature, so that it could be a result of some type of biological process. But this is all happening in the clouds of Venus's atmosphere, not on the surface. So, this is kind of one of these first glimpses at really our next door neighbor that, might potentially have some type of life in its atmosphere. And honestly, we have a lot of work to do to study, this detection further and confirm it and verify, okay, what is the exact process? Because the more we can learn about Venus, the more that helps us study exoplanets. So as we continue to search for life on them as well.
Amazing. More detective work. I love that.
That's right. This is like a hint, right? So as a detective, you need to go there and continue to investigate and put the pieces together.
Chung chung, planet hunters. Yeah, I want to see the Law and Order version. Wait, we have another audience question. Let me see if I can find it. Here we go. What are your thoughts on TRAPPIST-1? This is also from that one guy in your class. I understand that it's still under revision due to frequent radiation flares, but isn't this ruled out if it's tidally locked? Farisa, since I have no idea what I just asked, can you answer?
Sure, thank you. TRAPPIST-1, if I may show image number 4, I actually brought an image of TRAPPIST-1. It's such an interesting system. TRAPPIST-1 depicted here is an artist's depiction of the planets, and there's 7 almost Earth-sized bodies. I mean, if you compare to the bottom part of the picture there's Earth, Venus, right, Mars, and Mercury, and more or less, where they would orbit around the sun. And notice that the green regions, that would be what we consider the habitable zone. So for TRAPPIST-1, this system around another red dwarf star, it's a very faint star. So therefore there's these 7 that we found, right? 7 Earth-sized bodies orbiting really, really close, but there's 3 of them that are in the habitable zone. We only have 2 bodies in the solar system for us, Earth and Mars, that orbit in the habitable zone. Well, TRAPPIST has 3. And the problem with orbiting the star so closely is that you can get tidally locked, kind of like what the moon is doing around the Earth, that is always facing us, or the same side of the moon is always facing towards the Earth. So over here, these guys would be so close that they could get tidally locked and bombarded by solar flares from or stellar flares from their star. But even if they were tidally locked, it doesn't mean that there wouldn't be a comfortable temperature on one of these planets, because if you're tidally locked, so there's one side that is perpetually looking towards the star, that would be really, really hot, right? But then there's the back side that would be perpetually frozen. Well, between frozen and super hot, you have to have a comfortable region around it or somewhere, right? So they remain very interesting targets for further investigation. We have not established fully like their atmospheres and what's going on there. There's definitely 3 in the habitable zone, Earth-sized like bodies. So we need to continue studying.
Yes, and create a warp drive so we can go look at them.
Yes.
That's amazing. Oh, wait, we have a question from YouTube. This is from Shannon Morgan. First, Shannon says, thank you for talking to us. For a few sectors, TESS had to point much further north than planned due to excessive contamination by stray light. What made this stray light unexpected? Nicole, I'm going to throw this to you because apparently you and Tess are very close.
We are. I mentioned, we're BFFs. This is a really great question. And it is, it's an important point about, TESS, the way it was designed was to survey over 80% of the sky essentially in its first 2 years of operations. But when it switched to observing the northern hemisphere, we did have to shift the way it looked at the sky because there was extra stray light basically coming from the moon and the Earth, and it was impacting the cameras and causing some of the images to kind of blow out essentially and be saturated. If you want to think of it like that. And so we had to do this for a couple months for tests. And this was not in the original design plan, essentially because the way the cameras were designed and coded, we just thought the coding on the cameras would mitigate any effects of stray light a little bit better than they actually did in practice. So it's one of these things, whenever you launch a space mission, there's always going to be things that you encounter once it's up in space that, you encountered or you took into consideration on when the spacecraft was on the ground. But there's always little effects that you do have to consider once you're actually up there flying around in orbit, and you have the sun and the moon and, everything's up there, right? That you have to consider. Mm-hmm. That was a great question, though.
And you couldn't just do a software update and test some Snapchat filters to filter out the light? No.
I mean, we're not that close to friends. No.
Don't share a Snapchat. Okay, we have a question. This one's for both of you guys. What is your favorite exoplanet? And of course, you got to tell us why. Rita?
I'll go first. My favorite planet is absolutely the Earth, but exoplanet I am going to choose the one that is closest, that we've discovered that is closest to the solar system. This one is also an Earth-sized body, and it's orbiting around another M dwarf, so a red dwarf star. So it's fainter than the sun, but it is the closest. It's only 4.3 light years away, and it's orbiting in the habitable zone. So Proxima Centauri is a star that is closest to the sun, and it has an exoplanet orbiting in the habitable zone. So I think that one's going to be very interesting.
Proxima Centauri. Wow. I love that name. Nicole, what's your favorite exoplanet?
Oh, well, I have many, but if I had to pick one right now, I would actually refer to Kepler 16b, one of these names that's not very exciting, but if you pull up
not
image,
so Proxima Centauri.
I know, yeah, that's true. It's a little less exciting on the surface, but if you pull up image number 3, I brought this artist rendition where it's actually showing an artist rendition of Kepler 16, which is the star, and it has, or which is the larger star. And then there's a smaller star, the orange circle, and then there's a small dark circle that's a planet. And basically what you're seeing is there's a planet orbiting around 2 stars. So imagine you're on that planet, you see 2 stars in the sky. And this is what we call a circumbinary planet. And the reason it's one of my favorites is, if you think back to science fiction, it's reminiscent of Tatooine in Star Wars, right? And, how can you not love a Star Wars reference? So I love that, the Star Wars fiction that was thought of decades ago, we actually found in reality from the Kepler spacecraft that made this discovery of this planet orbiting 2 stars. So that's why it's one of my favorites.
Wow, that's amazing. I love this. This has been such a great conversation. I mean, we're talking about the journey from imagination to, scientific reality. And also, I mean, Farisa, the fact that you started your career after having a family, it's like, okay, Wonder Woman, do it all. That's incredible. But before we wrap up, you guys are amazing. Are there any final thoughts that you guys would like to, share with the audience?
It's within reach. Whether the information's out there, researchers, we publish everything we find as soon as we can. If you want to get involved, if you're a student, do an internship, right? Look into the NASA center or any institution that you're interested in working with and just look for their internship programs. It's a great opportunity to get your feet wet.
There you go.
Yeah, absolutely. And then if I can just add to that, 100% internships all the way, don't hesitate to reach out to people who have careers that interest you. It doesn't have to be exoplanets. It could be anything. But also, you want to, if you're interested in pursuing science, I mean, again, look everywhere for inspiration, essentially. Look to, movies, books. The reality of it is science is always changing and evolving, and we're always learning something new. So it's a really exciting field to be in. And you can bring that, more excitement to the field, the better.
There you go. Oh, that's amazing. Well, thank you both for joining us. This has been a great, great fun discussion. And now, when I say exoplanet, I won't have that blank look in my face. I'll know what I'm talking about. But it's been great to learn about the exoplanets and to learn about you guys' careers and about you guys. And folks out there, if you want to learn more about exoplanets, you can go to exoplanets.nasa.gov. And you can see this video, as well as all the other Universe Unplugged videos at universeunplugged.org, or just click on the link in the comments here. All right. Subscribe on YouTube, and you'll be the first to know when our next video comes out. And follow us on Facebook to catch our next live show. But this has been this live show with Nicole Colon and Farisa Morales, and I'm Phil Lamar. And thank you for watching Ask the Astronomers Live. See you next time.